Hello, this is Mohammad Barakat and welcome to Spark 2026, week 4. Today we will be discussing what is AI. So, let's start. AI is a sub branch of computer science which is just trying to do what humans can do better. Basically, you can imagine it could be anything, just sorting some files, or even driving a plane, or a bus, or a car. It's very wide. And this field actually had a lot of cycles of getting popular and getting not popular. And today we will be taking a look at the field in general, what is AI, and we will be focusing more on machine learning and deep learning. Those are the two most famous methods or subfields of AI that are available now. So, as you see, AI is a big topic. It has a lot of things, and we will be only focusing today on machine learning and deep learning. So, you can think about AI as, for example, things that are logic. For example, so if you are sick, then no school. If you are not sick, then work, or something like that. Very simple, but it's very powerful. And it actually is part of a lot of things that we know now. So usually problems start as some things in AI and then they change and become things that we take for granted. For example, you can think about when you are writing code and you have this autocomplete that is happening, or they like to call it IntelliSense. This once was once AI. And also you can think about search and sorting. A lot of those problems originated as AI problems and then became a separate field or just part of computer science. So AI is, we discussed, could be just very simple logic, uh, or it could be something more complex. And the more complex thing is machine learning and deep learning. Basically, when we were writing those logic and those patterns, we found very quickly it's very hard to capture everything. Like, how would you describe a tumor? It's very hard to describe. How it doesn't have a certain length, it doesn't have a certain width, it doesn't have a certain color. So it's very, very hard and very challenging to do. Yes, people were able to do very huge progress with classical AI, but it came to a limit. And people started trying to see things a little bit differently. What about if we don't try the exact rules and we just trying to see patterns in the data? So we want to see that it might look like this, and then this is a tumor. And in order to do this, we scientists tried a lot of different ways, but we will be focusing on the main three ones: supervised machine learning, unsupervised machine learning, and reinforcement. And just to give you a very high level idea, supervised machine learning, this is where you know what are the labels are. So you go collect a lot of examples. Say you want to classify um, tall people and short people, and yeah, from an image or something like that. What you would do is that you get a lot of images, and most of those images would have tall people, some of those images, and a lot of other images, and those other images would have short people in the photo. And then you mark this as 1 and you mark this as 0. And then you have a model here. We will be discussing later what is a model, what does it mean, a model. So let's just put it as a black box. And this model takes this dataset and takes this as well, and it learns to output either 0, short, or 1, long. And then that's during training. Then during usage, or we call it inference or testing, what you have is that you have your model that is already trained. You take a photo. You don't know if this is long or short. You just use the labels during training. During inference, you don't know. You just use your phone, go take a photo, and now you want to use it. So you input the photo to the model, and the model tells you 0. Then you know that this photo looks like there was a short person in there. And we do this in a lot of other things. What we just saw is called classification. You take a photo, you try to say, is it 0 or 1? Is it a short or long person? And that's it. You might want to try to do something else. What if I don't want to see how long or short the person is? What I want to know is how long they are. So instead of formulating my problem as I just did, no, I'm gonna do it a little bit differently. Okay, let's erase all of this and do it a little bit differently. Okay, we will get this time a lot of photos, but with each photo, we get how long you are. Okay. And then we give this to the model. Again, let's not discuss what is the model or how it learns now. And the model tries to think, okay, so this photo is 162, so it gives you as output 162. And then this is during training. So we have the photo, we have how long the person is, and the model is basically trying to predict how long the model is. And then during inference, or during testing, or during we have a photo now, we want to know how long you are. We take the photo with our phone, send it to the model. Remember, inference, we don't have how long they are. The model tells us, oh, this is very long person, 200 centimeters. And this is called regression, which means that the model is trying to predict not a class. Is it 0, 1, 2? A class that is it short, long, um, dark, white, whatever. No, it's trying to predict a number. And this is the second type. The third type that is very important to know is segmentation. And segmentation is basically trying to, from a photo, you are trying to say, okay, this is a car here. And you can imagine that trying to do this means that there's a human, someone would take a lot of photos, and then they would sit down and go, okay, this is a car, and then they would take this purple one and they go, and this is a motorcycle, and then they go and keep drawing every bounding area around person. And this is very famous, and it's very related to what you will be doing at Spark if you end up participating in Brett's challenge or in any tumor or any segmentation task. This is very famous in medicine as well. There's a lot of other supervised things that you can try to do. For example, you can might be interested in localization, which is just taking a photo and drawing a bounding box around the thing. So you say this is a human. You don't actually get the exact boundary around the human. You just draw a box around it. And uh, this is also very famous in medical fields. What I'm trying to say is that this, what you need to understand here is that supervised machine learning is not just about three or four tasks. There is a lot of tasks to do. But the idea of supervised machine learning is that you would go out, collect some data, and do get their labels, get what is the output, basically. And this might sound very nice, but as we just saw, it's very, very hard to do as well, because you need a lot of photos and you need someone to sit down and try to draw on every photo and draw everything. And the very famous thing that you would be thinking about right now when you think about AI is large language models and things like ChatGPT, Gemini, or whatever. And those also use some sort of supervised machine learning at the beginning. What they basically do is that they take a sentence and they learn to predict the next word. They actually learn on two phases, and today we will be discussing both. So the first part is that they take, for example, I want to. That's the input that you are giving. Sorry, my yeah, my handwriting is super bad. And they predict play. And then they take another sentence that says something like go to, and they would be predicting work, and so on and so forth. So what you are will be collecting are sentences and the next word in the sentence. And that's quite easy to do because we have internet. You can just go to internet and collect a lot of data and use it for training. So those were very nice ideas, but you come quickly to this idea that okay, that's nice, but that's also hard to do because in images you saw it's annotating this data set is not easy and it's not a fun task at all. And yes, it was easy in the language models, but they also faced another way. Another problem is that you don't want the model just to continue your sentence, but you want it to answer in a humanly way. You want it to answer in a way that human likes. And this supervised machine learning was not enough for this. So we will be seeing two other methods, as I promised, that are trying to tackle those two problems. It's too hard to collect the data and the labels. And I didn't mean this, but and the second thing is that uh, the length that it doesn't sound like a human, it doesn't act like a human. So how can we do it? How can we fix this? So yes, this was an example of supervised machine learning. You collect some data set, and then you say, is it blue or green, which is just um, uh, classification, basically. You and then yep, and then another example. Now you are experts, you know this is regression. Basically, what we are trying to get, we get an input, a distance from maybe the center of the city, and we are trying to predict the temperature. And this is basically a regression problem. Why this is a regression problem? Because, sorry, let's go back. Because now we are trying to predict a number, not a class, not green, blue. Now we are trying to predict a number. And then the last part that we will be discussing is segmentation, where the model is actually giving you an image with labels like this is a car, this is a tree, this is a street, and so on and so forth. Yep. Okay, so now we will be discussing one other solution. This solution is trying to see uh, h- how can we work without having labels. Having labels is nice, but it's hard as well. And what can we do to fix this? So let me get smaller here so you can see this check here over here. Okay, so what can we do? And what we want to do here is that we give it a lot of photos of, for example, a dog and a chick. And it learns that those two things are different things. It will not know that this is a dog and this is a chick, small chicken, but it will just know that those are different. And you can imagine that what it's trying to do is that it takes the dog and it predicts that it belongs to one of those areas. We call them clusters. And it would take the check and it learns that it belongs to some different area that is all chicken. And then it tells you, yeah, those two things are different. This is one class and this is the other class. I don't know what is this class or what is like this is a dog or this is a chicken. I just know that there is two classes and the dog is one and the chicken is in the other. And before we skip, so and it usually does this without taking it does this actually without taking any labels. So you don't tell it that this photo goes to class 1 and this photo goes to class 2. No, this if you do this, then this is supervised machine learning. You are annotating all the images. We don't do this here. In unsupervised machine learning, we get a lot of examples, but we don't get any labels. And there is a lot of ways to do this. Uh, I guess we will be discussing a lot of those methods, hopefully in the next sessions, but I just wanted to give you the idea that there is other ways. And finally, there's reinforcement learning. Reinforcement learning is basically the model is trying to learn how to behave in a way that we want. And what we do in this reinforcement learning is that, okay, we take the model and instead of telling it that this photo is cat, we ask it to do whatever it wants. We put it in a simulation basically, and it tries to select the label cat. And if it's correct, we give it a reward. If it's wrong, we give it a punishment. And you can think about this as if you are teaching a child basically. You are telling them, if you do your homework, we go to the zoo, for example. If you don't do your homework, then you are grounded. And reinforcement learning is trying to do the same idea. And this was the one of the major parts behind LLMs and the revolution that we are seeing today is that after they did the supervised machine learning, if you remember, we said that it takes a sentence and then it predicts just the next word. This is we they finished the supervised machine learning, okay, and then they took the model. Okay, so there is a model here that is trained to do this. Then they take this same model and they ask it, they give it a very long sentence. Your question. Hi, I am Mohanad, and today I want to plan a trip to Paris, for example. And the model gives you some output, some words. And then what they do is that they evaluate this, how good it is, how human it is. If the humans think it's very nice, they give it a very high reward and the model is happy. If the evaluators think it's bad, then the model gets nothing or gets even punished. And now the model tries to say not just the words that are grammatically correct, but also that sounds as if a human was speaking actually. And reinforcement learning has a lot of places that we have seen it make a lot of good progress. It's also very famous in robotics right now. So you basically do a simulation where you put your robot, but software version of your robot in a simulation, and you make your model try to move it. And the task would be something very simple, like just walk. And each step that the model does correctly without falling, it gets a reward. But if, for example, its shoulder touches the ground, then it basically is falling, so you punish it. And you keep doing this until the model learns how to walk. And you keep doing this again and again and again, and all of a sudden you have robots that dance. Uh, this is was like a very generic bird view of the important aspects, but there is a lot of other types. There is in under computer vision, for example, you can see there is like object detection. We talked about it. There is feature extraction. There is a lot of other problems in AI. Hopefully, in during Spark, you will get introduced to a lot of those topics and you will find what you want or love to learn. So now the very important question is how can I get better? How this looks very, very broad and hard to do. And actually it boils down to one basic idea: work hard and learn the basics. Don't cut any shortcuts in the basics. Don't skip mathematics and don't skip code. Don't make the language models or the agents do your assignments or do the projects. This will hurt you a lot. You are now trying to learn, trying to be perfect. So put all the effort to learn in the basics and all of the nice tools you can use later to be faster and more efficient and all of that. But try to take this chance during Spark to learn the basics very, very well. Ask a lot of questions. We are here to help you and engage in discussions and things like that. So, thanks. And hopefully, this was a nice lecture. And see you in the discussion. If you have any questions, please send them.